Good morning, madam. Myself Neeraj Kumar from CSCD section. My topic is on Stokes theorem. And moving on to the question, verify Stokes theorem for f bar is equals to 2x minus y I bar minus y z square j bar minus y square z k bar over the upper half surface of the sphere x square plus y square plus z square is equals to 1, bounded by the projection of the xy plane. So, and moving on to the solution. So, let's write the f bar first. 2x minus y I bar minus y z square j bar minus y square z k bar, and then write the dr bar, that is equals to dx bar dx I bar plus dy j bar plus dz k bar, and then f bar into di bar, that is equals to, it is the formula f1 dx plus f2 dy plus f3 dz. So substitute the f1, f2, f3 values in the formula. So here it is 2x minus y dz minus y z square dy minus y square z dz. And moving on to the next slide, next curl f bar. So the curl f bar, it is in the matrix form. So in the first column I bar, j bar, k bar, and then dou by dou x, dou by dou y, and dou by dou z, and finally 2x minus y z square minus y squared z. So on doing the calculations in the matrix, we'll get the I bar into minus 2yz minus of minus 2yz minus j bar to 0 minus 0 plus k bar into 0 minus of minus 1. So it gives I bar into minus 2yz plus 2yz plus k bar. So minus 2yz and plus 2yz will cancel, and it's only k bar will be left. So it will be written by the Stokes theorem. Here it is the formula of the Stokes theorem. Integral C f bar dr bar, that is equals to integral curl f bar dot n bar ds. So after writing the formula, let us write the LHS. The boundary C of a circle of a surface is in xy plane. So it is given in the question. Here x is equals to cos theta, dx is equals to sin theta, d theta, y is equals to sin theta. So in the LHS, integral C 2x minus y I bar minus y z square j bar minus y square z k bar dx I bar plus dy j bar plus dz k bar, and then here it will become 0, and then in the next step 2x minus y into dx will be only left, and then 2 into substitute x and y values here. X is equals to cos theta and y is equals to sin theta d theta. So substitute them. Integral 0 to 2 pi 2 into cos theta minus sin theta of minus sin theta d theta, and then 0 to 2 pi, so multiply 2 with the cos theta minus 2 cos theta sin theta plus sin square theta d theta, and then sin theta into sin theta will become sin square theta d theta, and then apply integration to the next step also. 0 to 2 pi 2 sin theta cos theta d theta, and then in the next step it is the formula. So sin square theta is equals to 1 minus cos square theta by 2, and 2 sin theta cos theta formula is sin 2 theta. Write those formulas, and then here 1 by 2 theta from the limits 0 to 2 pi minus 1 by 2 sin 2 theta by 2 from the limits 0 to 2 pi, and minus of minus cos 2 theta by 2 from the limits 0 to 2 pi, and then substituting the upper limit and the lower limit, will get 1 by 2 2 pi minus 1 by 4 sin 4 pi plus 1 by 2 cos 4 pi minus 1 by 2. Solving this equation will get pi plus 1 by 2 minus 1 by 2. So here plus 1 by 2 and minus 1 by 2 will be cancelled, and remaining the pi will be left. So in the LHS we got pi. Let's now check the RHS. Put x is equals to r cos theta and y is equals to r sin theta. Dx dy is equals to r dr d theta. So RHS formula is integral curl f bar dot n bar cap ds is equals to integral s k bar into k bar dx dy. So then after applying the limits, so the limits are from 0, theta is equals to 0 to 2 pi and r is equals to 0 to 1. Apply the limits to the equation. Integral 0 to 1 and integral 0 to 2 pi r dr d theta. First and in the next step, integral 0 to 1 theta from the limits 0 to 2 pi and r dr. Substituting the limits in the theta, we'll get integral 0 to 1 2 pi r dr, and then solving in the next step we will get it gets cancelled r and r, and in the next step we'll get 1 minus 0 into pi. So 1 minus 0 is 1, and when it is multiplied with the pi, the answer is pi. So in the previous LHS we got pi as an answer, and in the RHS also we got pi. So LHS is equals to RHS, hence Stokes theorem is verified. So thank you.